Introducing the new DigiCert. As the leading provider of high-assurance SSL, TLS, and PKI certificates, DigiCert is all about improving security across the web and IoT. DigiCert is committed to helping customers and partners successfully deploy identity, authentication, and encryption solutions. They'll even help you figure out which certificate you need to secure your web domains, apps, devices, and more. Check out the Cert Wizard tool under the SSL tab on digicert.com. The average time between being hacked and realizing you've been hacked is 1 year. Can you afford to let an intruder roam your network for that long? Can your company weather the fallout when this comes to light? Black Hills Information Security can find the bad guys in your network and train you to do it yourself. Email consulting@blackhillsinfosec.com to find out how a hunt teaming engagement can help you find a persistent threat in your network. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW. Welcome back, everyone, to Paul's Security Weekly. I want to make an announcement. On our on-demand webcast series, we've got a new on-demand webcast that's there, The State of Endpoint Security. It's really awesome. Rapid7, Patrick, was one of the sponsors for that, in addition to Minerva Labs and Endgame. I got a chance to catch up with Endgame. Two of their folks were at Source Boston, great conversations. One of the things I like about Source, I get to talk to people, and we're talking about the State of Endpoint Security webcast, and actually talking about because Carbon Black was there as well, which made for interesting conversations as they're direct competitors. We're talking about the landscape of the endpoint security market. So you can hear our take and our sponsors' take on the endpoint security problems and solutions by visiting securityweekly.com/on-demand and registering for that. Now, in the interest of full disclosure, anytime we have a security incident, well, I'm disappointed, because usually it means we made a mistake, and everyone makes mistakes. I mean, let's be honest, right?
It's how we learn.
It's how we learn, and I would like to share that with our audience too, in effort of full disclosure. Also, the nice part about doing on the show is you get some insights into my forensics process, which is really lame. It's nothing deep technical. It's more just like that was kind of interesting kind of security incident. Due to basically some recovery of a service that was down, porting that service to the cloud, now putting all the security controls there, led to the security incident, which also I think represents something I don't remember ever talking about this particular threat on the show before. It's kind of interesting. The reason we're talking about it is because we fell victim to it, which is interesting to me. So this comes from my presentation. I presented this at Source Boston. I also wanted to disclose it on the show because it does represent our handling of a security incident here at Security Weekly. This particular incident happened on April 1st. And the way we were notified was one of our AWS instances, or EC2 instances, was just cramming out a massive amount of data. I should also say that Joff Dyer is here on the lines via Skype. Joff, welcome.
Hey, whoa, turn the mic on. That's always a good idea.
Good idea. Good idea.
To be here.
Looking forward to your input on this as well. As we're getting into a little bit of Linux stuff and looking at some Linux binaries and what they do as well. So awesome. What we traced this back to was we had Docker running on an AWS EC2 instance, and there was a Docker container that was uploaded to one of our Docker services, our Docker servers. And we're like, well, that was kind of interesting. It turns out that was the cause or the source of this distributed denial of service attack that was being sent out to some poor victim that we apologize to on the internet. If you're an IP address, no, I won't give the IP address, but if you're a victim, right? Yes, it was sending to 127.0.0.1. In our rush to the cloud, obviously, controls were not put in place that needed to be, and we'll talk about those. So it turns out that we didn't really know what we were doing with this particular thing. And Docker does warn you. Essentially, this is a message from the Docker daemon or the Docker service that was running on our Linux toast. It was basically saying, look, you've enabled Docker to listen on an API. We'll get into why we did that in a little bit as well. And if you don't use the TLS verify setting, which, Keith, correct me if I'm wrong, I think it works pretty similar to a Docker registry in terms of generating the CA certificates to do authentication between your various services that would access the Docker daemon API and your various developers or other services that would access your Docker registry. There has to be a trust that's done with SSL certificates. Is that correct?
That's my understanding, yeah.
So that this error message right here is saying you haven't enabled TLS verify, which again requires creating certificates similar to your registry to authenticate things to your Docker daemon API, which in the API I unfortunately don't have the exact command. And Keith, I don't know if you've done this because you've worked with Docker probably more than anyone else here today. And I can say that for Joe because we talked about Docker as well, and it's something Joe's looking into a bit as well. But so have you used the Docker API? Like, I think a lot of people don't even know that it's there.
Honestly, I haven't, but I haven't run into a situation where I felt the need to as of yet, but now I feel like I should go take a look at it.
Yes.
So quick question,
Jeff,
Paul.
yes.
Is the boldface capitals your emphasis or theirs?
That is theirs. That is the log entry. Other than the bold, that is the exact log entry. I did also take out one of our internal IP address, in the interest of not disclosing any of our even internal infrastructure.
Okay.
And so that container name was called GoGo, which is kind of ironic. I was a little scared because we have an internal server named GoGo because we named them after characters in the popular martial arts movie. Does anyone know the movie?
Kill Bill.
Kill Bill. And so that was the Docker container name that was uploaded. So if you look under the covers inside of Docker and you run some commands against your Docker server to look at all of your images and you dig deep, I probably should have put I was digging deep in the Docker directories to look at the metadata around containers. You can find all the hashes for that as well as the name. That was the repository 191448885/gogo. And that was the image that was uploaded. Now, what's interesting is I said, okay, well, essentially I knew what the motivation of the attackers were because we were sending out a denial of service attack. So I'm like, well, they probably compromised our Docker instance in the interest of using it solely to send out a denial of service attack. When I don't remember what I Googled for, but I was Googling for a bunch of things like uploading rogue Docker containers, distributed denial of service attacks with Docker. Eventually, I stumbled across a blog from Aquasec, who is a container security provider. Keith, is that term that accurately? I think they have a scanning. I think they're limited to scanning solution. I could be wrong though, but they do have security solutions for Docker.
Container security. Yep, that's literally how they market themselves.
Okay, so they actually had an instance where they put up a honeypot on purpose, which, oh wait, no, isn't that what we did? No, I wish I could say that's what we did, but we didn't. They set up basically an open Docker daemon with the API open and like accepted images and got to see what people were uploading, and they found ones that were being uploaded for crypto mining. So, I mean, this makes sense, right? It's a really easy opportunistic attack to look at Docker instances that are open APIs, upload your own Docker container. They're really easy to create. And you can put whatever kind of malware or malicious processes you want inside of them, and it just is running on other people's Docker containers. I imagine they're scanning the internet, looking for open Docker containers and uploading them, and Aquasec describes a very similar attack. So you can look at their full blog post where they're analyzing it, and they go into some nice detail that they get from their tool for Docker container security. So I thought that was a great resource. And the link to these slides is in the show notes. So if you go to wiki.securityweekly.com, this is episode 559. I got that 559. And you go to this episode in this technical segment, you can get a copy of these slides, a link to them.
Hey, Paul.
Yes.
Quick question. How did you figure out that something was wrong?
We got a notification from AWS that we were using like way more bandwidth than normal, and we were sending excessive amounts of traffic. So that was the indicator of the initial compromise. Had they just been mining cryptocurrency, we might not have realized as early as we did with the denial of service. However, we did enable, and Keith or others may know the exact name of the AWS service you enable to monitor the consumption and performance and CPU usage on your containers, we probably would have seen it. I mean, we don't check that necessarily every day, but we would have seen it in the dashboard that we use to monitor. I think we did set thresholds too, so we would have seen a lot more CPU cycles and said, whoa, what's going on?
And definitely when you get the bill.
And hopefully before we got a really large bill, right? That's the why.
Usually what ends up happening is, depending on the cloud service provider you use, what will end up taking place is they will notify you when you've gone over some sort of limit of usage for that month as well. So that's like the first indicator that you've already, you're in a bad place.
Yeah, it's a good question, Jeff. So we got a copy of the container, right? Because that container is running on our instance. I mean, we instantly shut down the image, made a copy of it, rebuilt everything, and started doing the forensics on it. And so one of my initial paths was I basically had the file system from the container, and I could browse that file system and look at all of the binaries and configuration files inside that container. What I found were some interesting things, and there were two files really just by manually browsing. I looked at files that looked kind of out of place, and in my discovery, I saw a Java binary on the system that was not stripped, and the name of it was Java, and it was only 1.1 meg. I don't think ever in the history of Java has the binary ever been as small as 1.1 meg. And so
that's a clear indicator of compromise,
right
there.
That was a huge flag. I'm like, what is that binary? I'm like, obviously it's not Java. And also there was another binary on the system, which I would learn later that is an exact copy of itself. So it actually made multiple copies, like thinking if you found one copy, maybe you wouldn't find the other. But this binary was called Pythno. Like instead of Python, it was Pythno. I'm like, well, that's weird. Like either the package maintainer made a typo or a spelling error. That's kind of suspicious. So I was like, well, I can upload these to VirusTotal and see if anyone else knows about them. I'm like, that's a good thing. I'm like, I could go find some tools to disassemble them and look at the flow and look at what files they created. Or I found today in 2018 that it's pretty easy just to upload them to VirusTotal, and they pretty much do that for you, which is kind of awesome, which is why it's kind of a really lame. So when I did, I would reference this, as we say in security, lighting up like a Christmas tree. Which and ironically enough, it is green and red, which is interesting. So when I uploaded one of these files, it was caught and discovered a signature or detection mechanism existed in a very large percentage of the AV providers that are in use by VirusTotal, which to me was an indicator that this was not very sophisticated malware if it was already discoverable by all of these various antivirus vendors. And then VirusTotal gives you this nice screen. It's really hard to see in this instance. Again, the slides are available. But essentially, this was a listing of all of the commands that binary was running. The files that it left behind was also in there. The processes that were created and terminated, and some of the function calls within the binary, as it wasn't even stripped or obfuscated in any way. And so you can see things like attack base and packet attack and attack SYN, attack ICMP for some of the function names. I'm like, okay, well, the names of the functions are consistent with a distributed denial of service bot. The names that the antivirus companies were calling them were also consistent with that. In fact, if you read some of the names and then Google search for them, you could find that this was Trend Micro that basically said, yes, this particular binary is in fact a backdoor dropped by malware and used to, and in other descriptions it said basically it was used to send out denial of service attacks. It's like, okay, well, now I've got a consistent motive with what occurred on our systems, with what I observed in the binaries, with what VirusTotal was able to tell me about these binaries, with what I could corroborate on the Aquasec blog that they used in a honeypot that this type of behavior was happening. Their case was crypto mining. Mine was denial of service. Very similar class and category, I think, of attacker and style of attack. So essentially, I traced this down to by reading through the Docker documentation about how I get it to listen on an API port, which is the first in the command line reference, and then how to create the key pair. So how you remedy this vulnerability Our initial remedy was to use firewall rules inside of AWS to say only RRP addresses can access, our instances as our application is not public yet. So we did that initially, after rebuild it and doing forensics and making sure we didn't have the same vulnerability. One level was to create firewall rules around that. So the remediation is pretty straightforward. Rebuild the environment from scratch from known good source code repositories that we had. We pulled them down from GitHub. We rebuilt everything, fresh copy of the OS, and then went on to understand, well, how did this happen? And it was because Jenkins was using the Docker API to do some automated testing and such, which led it to be listening on this API. And I traced it down to a docker.services file for systemd, which had the -H, then TCP://0.0.0:2375, which is the non-SSL port that it was listening on for no authentication. The link in my slides, if you're listening to the audio version, there are links in my slides that tell you about this feature and also how to enable it, and then how to secure it with the TLS verify command. So those documentation, those links exist in the presentation, and documentation exists so we can remove that requirement, add the authentication in, and I think have a much better levels of security, right? First level being some filtering controls and firewall controls. Second level being authentication on the service. Third level being making sure that we monitor our AWS environment first, so that we're notified when certain thresholds are met. You could also couple that, likely if you had a larger AWS implementation, there are third-party providers that will do some of that monitoring in more detail for you. Our configuration of our servers has to be scrutinized as well. So we need to make sure that when we're rolling out new systems, that they're automatically checked to make sure that this particular condition and configuration doesn't exist. And if it does, make sure it's the secured version and flag it if that configuration is trying to go out into production that represents that insecure configuration of our Docker host platform. You can also do that in your containers as well. And we talk about that in Application Security Weekly, and I covered more of that in my talk as well, and how to protect your containers. Layered Insight is a sponsor of Application Security Weekly. You've heard Matt Alterman and others. John Kinsella from Layered Insight was also a great help in providing us advice and actually doing some of the forensics alongside of us when we told him about the security incident. He actually has some free, which I linked to in the full presentation, a free slide deck on scanning containers, which is one of the things that Layered Insight does. And there's lots of open source and commercial ways to protect your containers to kind of build upon our security architecture, and those are things that you want to certainly consider implementing as well, because while this attack was against the Docker layer, your containers could also contain exposures as well. And now I kind of get this indication that attackers are looking for this, right? I mean, this is a very basic attack, very simple, not very sophisticated, but they're certainly looking and now aware of Docker to be able to use that in a malicious way, in an unauthorized way, which I thought was kind of interesting.
I got another question, and it's probably more for Keith than you, Paul. What would have helped you more at Security Weekly to prevent this from happening in the first place? DevOps or DevSecOps?
Oh, no, you
He went there.
So at the end of the day, first of all, DevSecOps is a myth. You're not doing DevOps if you're not including security. Drop mic. Secondly, honestly, with the containerization as it exists, doing DevOps here would have looked something like making sure that the actual container is using only the right amount of memory, only the right amount of CPU. I mean, you've got those things like down to the micro utilization level, right? Because at the end of the day, especially for larger companies that are doing this right, they are micromanaging the size of these things to the point that it doesn't cost them hundreds of thousands of dollars for utilization.
Keith, you bring up a great point. Your container security and controls solution, before AWS notified us, we should have and actually we're testing out a couple of open source and a commercial solution for this that monitors the containers, so you can tell the controlling system, hey, look, if this starts sending out a large amount of traffic or starts consuming a lot of CPU, you can configure that to, I would imagine, to automatically just shut it down. So we could have probably just killed this attack even before, it started sending out a huge amount of traffic. We probably could have also noticed that, a new container was uploaded to one of our systems from our container security system, depending on what we're using and how we're using it. So there are a lot of ways we could have, Keith, right, from the container platform, be able to manage, monitor, and control that.
The DevOps is version control, utilization of the resource, fast feedback loops, monitoring. Like there's all sorts of things here that,
yes,
again, for everyone listening, if you're worried about DevOps versus DevSecOps, just remember, you're not doing DevOps unless security is included as part of the process. Full stop. There is no DevSecOps. It's just DevOps.
I agree. Questions, comments, feedback?
So Paul, I actually have a curiosity around how they got the container into your repository and effectively were able to make use of it inside of your AWS instance, right? Because somebody had to spin that up. And was it your container? Like, did someone replace one that you already had? Like, how did that all happen?
It was their container. That they
Got it. So they basically put their container in your repository, but then how did they turn it on inside of AWS?
So they uploaded a container to the Docker service directly that was running on top of our AWS instance via the API. Using commands, in my research, I found that there was a Docker machine component. There's also Docker CLI stuff as well that basically lets you upload a new container and run it via API commands. It's basically like a REST API that you can just issue commands like you would on the Docker command line to say, Docker pull, this container down, and Docker run this container, with this Docker file or whatever, or just run this container, or run this image rather. That you could do all those same commands with the API. So they basically had shell access, command line access to a Docker instance, and through those commands were able to upload it.
It's like remote SSH commands in effect, right? So in this sense, though, it's remote Docker commands where it's the push and start effectively.
Yep.
Huh.
Yep.
Now,
so that actually raises an interesting possibility. If I may interrupt a second, and that is, there could be targeted containers designed to start enumerating your environment from the inside, rather than just denial of service, right? So if you've got access to the API, there's much worse damage that actually could potentially be done.
Absolutely. You can get a list of all the running containers and get a lay of the land where if you didn't have that, let's say you were just able to upload a container, typically by default, those containers aren't going to be able to access other containers or gain access to services, but the API layer does. So it's really important when you implement Docker in this case, or any container-based system, to make sure that there's always proper authentication to all of your services where you're pushing and pulling code or pushing and pulling containers. Essentially, it's a very similar process, right? You're checking in and checking out images in a registry example through the API. You can upload and execute containers. It's important to have strong authentication onto those containers. And that authentication, I noticed that when you're using the free version of Docker, for example, like there's not a lot of options. Like basically you configure the certificates. I believe, and I don't know if anyone has experience with Docker Enterprise, that there are much better options for authentication and authorization in these various processes, because you've got maybe thousands of containers and multiple development groups, and how do you manage access to all of these repositories when you've got thousands of developers and tens of thousands of containers?
Yeah, it's securing your control plane is really what you're talking about, because it is the control plane, right? It's the thing that drives all the other containers. So it's a pretty severe issue if the control plane is exposed like that.
Yeah, and I mean, there's a control plane underneath that in the operating system in the kernel, and some container solutions do live in the kernel and would have detected this. And basically, if they're in the kernel, they can say, "Hey, bad container, you go away. You have no more access," because Docker rides on top of the OS and kernel. Keith?
All right.
So I have a question, Paul, also around the concept of the Docker networking, right? So you and I are familiar with the ability to create, consolidated networks where certain containers can talk to one another.
Yes.
I'd be really curious to know if you can then take the Docker container that you're maliciously uploading into this repository, and then just say that its network is whatever, network might exist inside of your actual Docker container network, and then start executing commands against REST APIs inside of that network, right? So the main container is supposed to talk to the database, is supposed to talk to these other services like the web server. And so to that end, it makes me wonder if you can almost maliciously inject your own container and then talk to the network of Docker containers inside of there, execute commands, and gather and like exfiltrate data from it.
Yeah, that's a great question, Keith. I know that you could, if you had the ability to like you run Docker commands on an environment, right? You could create a new container and put it in whatever network that you want, because the definition, so if you could read the network and then say, okay, well, I want to be on this internal Docker network, I know what that is. You'd put that in your Docker file when you build the container, and you would build it, and it would have access to that network. I'm sure container security solutions that's a monitorable event. Like, I just added a new container to my network. That's something I would want to know about. If you don't have that, an attacker could do that. However, the trust that containers have between each other would be interesting. So like, I explicitly say that my database container will accept connections from my application server container, and I do that in the definition of the MySQL container, right? I say link to, I think it's that way. Is it the relationship that way, Keith? I don't remember. I think so. I think I would say it trusts, right? It trusts accepts connections and links to those containers. If I put a new container on that network, it's not going to have that linking. I'm not sure how, if there are attacks against that, certainly that's my concern, right? How do you bypass that trust relationship that you define when you create all of your containers? But the way that I've observed it is that if you put a new container on the network, it really wouldn't have access to anything or be able to talk to anything, because you haven't created that trust. And if you don't have access to the other containers, then you can't do that.
I'm pretty sure you could enumerate the networks, though, as one of the steps on attack.
Yeah, for sure.
If you can enumerate them, you could definitely put a container on one of those networks. And bridging's pretty common in Docker that I understand with the Docker that I've done. So I think it does speak to exactly what you said, Paul, and that is you have to think about your security architecture between containers in the way you're building up your particular micro segmentation, if you like, your particular architecture for the application at hand, and think about these malicious use cases, right? What if the container goes rogue is really the question we're posing here.
Sure. So that's what happened. That's how we fixed it. Those are the lessons we learned. I thought the recommendations on top of that were fantastic. We actually talked a lot about container security, some of which we cover on Application Security Weekly. But great discussion. With that, we're going to take a short break, come back, and talk about the security news. Stay tuned.